Hi, my name is Jonathan. In the last video I posted, I covered making this threaded collar. When I made this collar, it wasn't fixed, it was just loose on the thread, so I've had to make a lock ring, in effect, another threaded ring to go on here to hold it in position. And I've also had to rethread that ring when I had some problems with the thread, which I'll cover as well. So this now will move with the drill. This is the whole point of doing it, so that I can set a guard and a scale and so on to move up and down with the drill. I couldn't find any steel bar of a sufficient diameter to start the job, so I started with a piece of flat plate and decided, well, if I drill a hole in the centre, I can bolt it to a tapped arbor in the lathe and turn it round and work on from there. I started turning the square using a high-speed steel tool, but the edge of it kept blunting very quickly, so I switched to a carbide tip tool, and that was much better. It kept its edge very well. To be able to cut slots around the circumference of the disc so that I could use a C-spanner, I needed to find a way to hold it so that you could line up one slot and then pivot the disc from slot to slot to cut each one without having to rejig the fixture in any complicated fashion. I used the 90-degree fixture that bolts to the lathe cross slide and machined a large washer that I could put a pin through the centre of and through the disc that needed machining, and screw it all into a T-slot nut to hold the work in position. The T-slot nut being quite tight in the slot didn't move, so that was fine. Can't really see from here, can you? After the first slot, I realised that with slots 200 thou or 5mm deep, I could cut them in one go if I turned the cross slide slowly enough by hand, and that worked fine to cut the rest of the slots. The next problem to solve was how to mount the disc in the lathe and bore it out and cut a thread in it when most of the metal would actually be cut away. So in the end it was pure coincidence. The slots I'd cut for the C-spanner matched up with the slots in the faceplate. I was able to put bolts in from the back of the faceplate, put nuts on first to support the work and keep it away from the faceplate, then the work, and then another set of nuts to actually clamp it there. This is the matching thread for the one I've got to cut, and that fits. I don't know if you can see it there. If I zoom in a bit, you can see that I will be boring out this plate to just below to the minor diameter, which is the inner dimensions of this thread, and then thread cutting it, and there's still extra to spare once the thread is cut, so that as I bore it out, the wool plate doesn't collapse or weaken. That's the plan anyway. We'll see how it goes. I started out by drilling as much as I could out of the disc and then just boring it out to get somewhere near the correct size. I used the same carbide tool as I had for the external diameter and an extended tool holder to give it room as the nuts and bolts were sticking out and were catching on the tool post. I wanted to get the thread right whilst I'd still got plenty of metal to spare before I got to the actual minor diameter for the final thread. So I started by using a tip tool, but I made the assumption that this tip tool that I bought advertised as threading internal would have some rake on it and would have a decent tip, a decent edge. It turned out not to be the case. I put some engineer's blue on the tool tip, and this showed that whilst it was cutting, it was also rubbing below that. I don't know how much of that you can see. The blue that I put on the tip has been taken off the top surface here, but also down the front edge and down the back edge. The tool had flats on the top and the bottom, so when held in the tool post it was only going to align in one position. And when I put it against a 90-degree block, I realised that there was actually a slight negative rake, so there was no way it was going to cut nicely. I'm going to replace it with this indexable threading tool. The new tool also had a flat, but you can see in this picture that when it was fastened down, the tip is at 12 degrees and that gives it 12 degrees rake. And whilst I don't have a wheel yet, a grinding wheel to sharpen carbide tip tools, at least I'd be able to change the tip or index the tip to get a new edge. So with a new threading tool to try, went back to the lathe, put in the boring bar again, cleared out the old thread, and then put in the new indexable threading tool to try that out and see what sort of thread I could get with that. Right, break the hole number. Into 10, back, break the whole number, zero, into 0, back, out to 0, and another 10. I think I can see some chatter. I'll take the camera around the front. I can see it on the video screen at about 3 o'clock. I've shortened the length the bar is sticking out, cleaned up the inner diameter and had another go at threading, and it's still got the on-off pattern. I don't know if you can see it with the camera. I then changed the tip, and upon taking the old one out I found it could have been in tighter. So I think that may well have been a major factor in the cause of the chatter. It seems to be much better after I put in a new tip anyway. So as I'd still got metal to spare, I used the boring tool to clean up the chattery thread and had another attempt on the thread, and as you can see here, it looks quite nice. It cut nicely and it sounded nice. I was quite happy with this, so decided to use this setup for the final thread. I used the cross slide rather than the compound slide to put extra depth on the thread each time I cut a bit more of the thread out. Back out. So happy with the thread cutting technique I was going to use. I could now go for the final diameter of the bore, the minor diameter of the thread, in preparation for the final thread cutting. .891. Number 16. 75, 81, 91. With some blue, it might help see what's going on. Into 15, out, into 10, out, out to 10, into 5, out, back to 5, and another 5. Right, let's try the test plug. Okay, so back in again. Into 0, out, .95, into 95, out. When I made this threaded test plug, covered in the previous video, out of aluminium or aluminum, depending on where you are, it was to test an aluminium part. That's the only reason I can think of that I didn't make it out of steel. And to cut a long story short, I ended up with the measurement across the threads of the test plug was about 10 thou smaller than it should have been. Now, I had a bit of a problem with that on the previous part, which I managed to rectify. Here, I know that the test plug is 10 thou small across the threads, and planned to make some allowance for that. Exactly what that means, I'm not quite sure. But here we'd gotten to a point where I had to go to do another job. I didn't get back for 3 days. Well, you'll see the result. Right, we'll see if it fits the drill. Yeah. Oh, it's tight. It's only going on about half a turn. I haven't made a C-spanner for it yet. I wonder if this oil filter wrench will get it. Oh, it's still tight. Well, it would be. I don't think I'm going to get it much further, to be honest. At this point, thinking that I may well have to make the part again, starting from scratch, I ordered some 4-inch diameter or 100mm diameter steel bar so that I could make a test plug out of steel that was the correct size and the new part. But whilst waiting for that, thought, well, can I take the existing part, put it back in the lathe, line it up and effectively chase it out or enlarge it. All that work and it doesn't fit. So you can see I've got the lock ring in the 4-jaw chuck. I've got the lock ring in there and my test gauge in that, and the dial gauge on the minor diameter unthreaded part of the test gauge here, which is the best thing I've got to the thread being true. How central that is and whether I can line up the tool. You can see here's the actual cutting tool. Test plug out, tip into there, and whether I can line it up with the thread, I don't know. We'll see. Whilst this setup allows me to centralise the lock ring by clocking in the test plug also expands, juts out at the back of the lock ring and butts up against the back of the jaws of the 4-jaw chuck, so it's holding it square that way as well. Well, we've got 1 thou movement, means we're half a thou off centre. It's pretty close. Not sure I'll get any closer, to be honest. And as I've got to take more than 1 thou off, I don't think I need to. Can't remove it. it seems that whereas before when I had the lock ring clamped to the faceplate, there were no radial forces on it. Now I'm using a 4-jaw chuck. Those radial forces are pressing it in and clamping it tight on the test piece. I think I'll take the camera back around the other side, at least we seem to have some light there. So by still being engaged with the feed, doing this is winding the tool in, and then I should be able to line it up on a thread using the compound slide, if it's all true and so on. And all I can see is not cutting a new thread, which is exactly what I want. I want it to be in the groove, man. The movement or the rocking of the tool you can see here is because the camera is freestanding behind the lathe, and each time I pull on the chuck, the whole lathe stand, which is on casters, and the tool post move slightly and then move back. So it's moving relative to the camera. Gouging out the thread again. You'll see here the tool hit one of the jaws of the 4-jaw chuck, so it just shows there's not much room behind the part. I'm going to change the tip round to a new one. I think I spent about 10 or 15 minutes turning the chuck by hand with the cutting tool feed engaged, up to 95. Tweaking it to make sure that the cutting tip actually lined up with the existing thread. Wait for the one to come round. Into 90, back, up to 90, and another 5. Look for the 1. Might have broken the tip. Yep, broken the tip. We'll get another tip. It's a lovely sunny day and it's a Friday and this road goes to the coast. So, sorry about the noise. Right. Back and forth, a little bit of play. So we'll pick the middle point, wind it out. Wait for one. Doesn't look too bad actually, so 90, into 90, back. Better try the test plug. Just give a bit of a wipe round with this wire brush. Right, how are we with the test plug? Tighten it up again. Right, I've gone into 90, back out to 90, and another 5. Wait for the one to come round. Missed it. .85 in to 85, back, out to 85 and another 5. Wait for the one to come round. We're on 80, into 80, back, try the test plug again. Screws up all the lighting because it's aluminium and it reflects. So if I can zoom out. Put off the LED lights because that seems to be worst. It's not very good, is it? Try again. It's turning quite freely at the moment. We're just about up to the back of the jaws. I know this is 10 thou undersized across the using the 3-wire method. So I'm going to take another 5 thou off, at least. Light back on. Wait for one to come round. .80 into 80. Back. Here's a bit of play. That's so much easier to turn. Oh, I haven't put the overhead lights on. No wonder it's a bit dark. Right, give it a go. Still tight. Oh. not quite a turn. Why it should go the other way and not that way, I wouldn't know, but it's desperation. I'll just try the oil strap wrench, oil filter wrench. Oh, it fits. I should have made that C-spanner, shouldn't I? Quite a tight fit, as you can probably, well, again, a low spot there perhaps. Hope that's on camera. The piece of steel plate I made the lock ring out of was an offcut from the top of the bench you can see in the background originally. So the idea is this collar will fit in this orientation. If I screw this on, see the thread's a bit looser on this, it's running it up and down. The aluminium is, what's the word, loosened, or being loosened. So the idea is to get it in the desired position, say there, oh there we are, that's working already up against the lock ring, and that's playing the shaft. So that's the plan. And it's working, it's already, that's locked to that. And I haven't even tried a C-spanner on it. Not that I've made one yet. Need to remove a chunk of the metal on the inner part of this block, leaving the outside edges to fix things to, and the back, which has got a thread in it. So I'm starting by turning away a big chunk from the centre. Out. This will tidy up. I may take some milling cuts across to square it off. I'm making a C-spanner. It'll fit this. Almost got to the right diameter for the, this will be the C. Or some part of it will be the C. There we are. We'll have to take the outside off with the angle grinder and weld the handle on. Right. Started out with the C-spanner. The basic shape is together. Got to grind it down so it works now, so there's room for it. We'll be able to get in there. There's not quite room at the moment. Fall off. It's getting better. So both these corners could come off. I'm going to get these corners off. Try and zoom in a bit. And centralise the collar. So I've made a lock ring and a C-spanner to fit it. The lock ring I'll remove that off a bit. Right. I screwed the collar up to give room to get this on, so now I can screw it down to meet it halfway. That's playing the shaft, which is a shame. Maybe I can do something about that. But that's now fixed. So this lock ring now is doing its job. I'm quite happy with that. I have learnt that, realised that making a test plug was a very useful addition to doing this work, but I should have made it the right size. It ended up slightly under by accident when the thread was a bit ragged. And I thought, well, we'll see if it'll do, but it would have been much simpler to make one out of steel rather than aluminium and get it to the right size. It would have helped things a lot. So I hope this has been of interest, and thanks for watching.